Good morning. So I'm Disha Roshan Bhakta, Assistant Professor, Department of Information Technology, Bansanga, City College of Science, Commerce and Management Studies, Powai. So students, as we all know, we are going through the subject data structures, and today we are going to continue with our introduction, uh, but we are going to see more on algorithm and its analysis. Fine, let's go ahead. Okay. So the objectives of today's session are going to be algorithm, importance of algorithm, analysis, and the complexity of algorithm. Okay. As far as I remember, and you also are aware of that in our previous session, okay, we have already seen about algorithm, what is the importance of algorithm, and why our first approach should always be designing an algorithm. I think we also saw a very small example of how an algorithm could look like. Okay, and if you remember, then at the end we have also discussed that. Initially, we can write algorithm, and then we should start putting the technical aspects on how that step could be achieved. So that was the basis of algorithm. Today we'll see some detailing about it also. Okay, and also we are going to focus on something what is known as algorithm analysis. Okay, maybe all the topics that we are going to see now, once when we go ahead in the approach of our subject, there will be many algorithms which we will be seeing, and at times you will also see that for a same aspect that you have to do, or let's say for the same thing that you want to perform, there could be two three alternative different ways to perform the same. Now in that case, uh, which approach should be chosen? Okay, giving you a very simple example, it might also happen that let's say a program is given to you, and maybe if it's, let's say, given to five students, the approach of all the five students will be completely different to have an output of maybe the code of it, and the way it is processed. So that's what it is. If the same, let's say, uh, uh, we call it as a problem is given, then it might also happen, students, that everyone will have a different way of writing the instructions, and everyone would have a different way of approaching it. So here, when we talk about algorithm analysis, okay, we are going to basically, understand what care we should take about when we are going to have an approach of algorithm, maybe in data structures as well as in general also. And then we are also going to find out that, given an algorithm, okay, what should be the best way, or what is the best scenario in which this algorithm behaves nicely. Okay, so that's what we are going to see. So the whole session is going to be more on algorithm, the focus on algorithm, and what things should be considered when we are designing an algorithm. Okay, so we're going to first start off with the revision of what algorithm it is, which we have already seen. So yes, students, I think we are already aware of that uh, the instructions given to the computer to solve a particular problem is known as algorithm. And algorithm is nothing but, we can say, a finite collection of steps which we give to the machine to solve a particular problem. Okay, the basic focus on algorithm is to divide a big task into smaller finite instructions. Okay, so that's the main reason that all the programmers and everyone, or maybe the system designers, always prefer to write an algorithm first. So that's what algorithm is. Okay, we have also seen, what are the major things that when we talk about algorithm. Okay, so yes, when you talk about algorithm, okay, you have to take care about the input. An algorithm must get an input. Okay, you have to take care about that the input which is given to the algorithm need to be processed correctly, and there has to be a particular output also. Okay, and also, we have seen that algorithm should be finite, which means the algorithm should terminate after executing certain number of steps, and yes, it has to be very effective also, which means every step that is written into the algorithm, uh, ch- uh, should lead to certain logical end on how why this step is written. The steps should be unambiguous, which means if I read it or someone else read it, there has to be a clear cut meaning of what this step wants to say. It should not be like that the step is just loosen up, and whatever language is written in the step, okay, everyone will have a different interpretation of that language. That should not be there. And yes, it has to be definite and feasible, very important. Okay, this we are going to because discuss today. When we say feasible, okay, which means a step which I have written in the algorithm, I should be able to code it. It should not happen that I have written something which is not which cannot be coded or which cannot be executed. Okay, that should not be there. So that's what the characteristics of algorithm is. Example, I think the same example we have seen in our previous session also, and yes, we can have many more examples. Okay, so the simplest algorithm to add two numbers, in which, as I already told you, the algorithm will always begin with a start step, and there will be an end step also to the algorithm, because it has to be finite. So let's say over here the first step is to declare two numbers, and we have just given an arbitrary name to those numbers as n1 and n2. Then in step 2 we have taken the input of the first number from the user, because we have marked in the first step that the first number is n1. In step 2, yes, we can denote that number as n1. The step 3 will talk about taking input from the second number. The step 4 will talk about addition of doing them, and the step 5 will talk about displaying the result, and then it's going to end. Okay, yes, because it is very simple algorithm. Okay, no matter wherever it is performed, or maybe if this algorithm I am going to give to 5 different students, mostly it will happen that everybody is going to come up with more or less the same solutions. Okay, but that will not be the case. Okay, when the problem is bit complex. Okay, when the problem becomes wide, when the problem becomes bit complex, okay, people do have different approaches to solve them. This is something which is universal, that when you have to add two numbers, this is the only thing that people perform. Okay, but when we talk about a different task, okay, let's say if we make this problem bit complex. Let's say if we talk about a task wherein in a program, let's say you have to take 1,000 numbers and display addition of, maybe let's say prime numbers separately, display addition of, let's say, odd numbers separately, and then somewhere you have to find out that which numbers the additions of which two numbers in prime, and this also comes common. So certain mixture of certain more and more and more operations, and then at the end I say that whatever result is being generated, okay, need to sort them. Okay, so yes, in this case I think it won't be that easy. Okay, all the students or all of you will not have the same approach to do it, because you'll start thinking, okay, you'll start performing those things, okay, with which you are comfortable, with which you already know, and what you will think of, okay, let me complete that portion, that portion of the, let's say, problem given to me, because yes, I'm very clear with that portion. Okay, I know what is the approach to that, and that's why your algorithm will also change. Okay, student one will start finding a different solution, and student two will start finding a different solution, because they might have different knowledge about the subject, and also a different knowledge about their own approach to solve the problem. So here, okay, why I gave you this example, students, because here, okay, there comes a scenario, where you are having multiple algorithms, and then you have to decide which one is fine enough. Because let's say ultimately at the end, all 5 algorithms, are giving you the appropriate answer. Okay, what answer was required? Algorithm one. So all 5 students, have come up with a solution. So wherein, if we execute their algorithm, if we execute this thing, then yes, the answer is coming. Okay, so now there is a dilemma. Okay, or that there is a there's a situation of choosing. Okay, so in this case, what should be done, whether to choose algorithm 1 or 2 or 3 or 4 or 5? So over here, basically, today we are going to much more talk on this scenario, that in this situation what should be done, what should be the aspect. And that's the same thing for a machine also. Okay, because and that's the same thing for a programmer also. Okay, so how do we get an awareness of what algorithm is best and what has to be chosen? Okay, so let's go ahead. Fine. So why we should do an analysis of an algorithm? Okay, so here we are talking more of an analysis. When we say analysis, we are trying to tell that there are multiple algorithms available with us for again doing the same thing, okay, not doing different things, okay, that's altogether a different story. What we are trying to tell is that there is a same algorithm for doing, or sorry, there is for doing the same thing, there are multiple algorithms available, okay. So let's say for problem 1, there is algorithm 1, algorithm 2, algorithm 3, algorithm 4, algorithm 5. All the 5 algorithms are helping to solve the problem 1. What should be done? What should be the analysis? Okay. So when we are doing the analysis, okay, we have to figure it out. The analysis should be done on what? Okay. What is there inside an algorithm, or what is going to be there on which I have to do analysis? Okay. So let's say if I talk about, okay, if I want to do let's say analysis of, let's say, Mumbai, then analysis on what? Okay. Do you want to do an analysis on weather, or let's say do you want to do an analysis on maybe say the traffic control, etc. So yes, similarly, when you are talking about algorithm analysis, okay, so analysis of algorithm on what? On what thing? Okay, on what aspects do the algorithm has to be analyzed? Okay, so that I can understand, or we can understand that yes, algorithm 2 is better than algorithm 1. So what exactly? What is the features which we have to see in all the algorithms, which will tell us that how these algorithms differ from each other, though they help us getting the same output, how they still do differ from each other. So that's what, students, we are going to see. Okay, let's go slowly, because this is going to be very important. Okay, um, and this is something, a long this has to be some a long term perspective, of a developer also. It's just not with respect to data structure, students. It has to be a long term perspective of any developer, that whenever we code anything, these are the things which we have to look into our mind. Okay. So let's start. The basic requirement to solve any problem is data and instructions to process the data, that is algorithm. So whenever, okay, irrespective of any application that you can think now, okay, let's say you have used n number of applications, you are already aware of n number of applications, whatever things which are there, and you can think now, okay, you will see that they basically comprise of two things, that is the data and how that data is getting processed. Okay, of course, data itself is a very big thing. Okay, as the application grows, the data is going to grow, and again, as the applications grows, the instructions to process the data is also going to grow immensely. Okay, but here, cutting it short, okay, we are just trying to tell that given any problem, okay, these are the basic two things which are going to be important. Okay, so which means that if I have different solutions for the same problem, basically I have to figure it out that in which thing data and algorithm is behaving nicely. Okay, so in that case, if that is the scenario, then I will say yes, this approach is the best approach to solve this problem. Now, and to efficiently process the data structure is used. Okay, so now when it comes to our first problem, that what should we do about our data? Yes, so if in problem if in any problem we are having the concern of data, we'll try to use data structure over there. Okay, at times we may use files also over there. So that's one thing, okay, that to process the data, we are going to make use of data structure. Okay, so that is understood. Okay, so there are multiple ways where multiple ways wherein you can store the data. Okay, you can use data structures, you can store it in files. Okay, of course, in later on you will also understand that you can store it in databases also. So that's one aspect. Okay, so there are alternative ways available to store the data. Next very important aspect is how to choose an efficient algorithm, because once the data is stored, okay, now when you talk about storing data, your the concern is very simple, it's just memory. Okay, so how much memory you're going to have, data is going to be there, and memory is not that expensive. Okay, so yes, memory is not as expensive as the amount of the resources the algorithm is going to use. Okay, so anyhow the data has to be stored. If the data is more, the memory requirements will be more. So it is as simple as that. Okay, so let's say if the data is going to grow, then the simplest thing that we have to do is we have to increase the memory. That is the only thing. But yes, now very important is to, as and when you are increasing the data, what exactly you're doing, you have to process that data also. And in this case, it is very, very, very important, students, that we should choose an efficient algorithm. So then what has to be efficient algorithm means what? Okay, what there has to be in this algorithm so that it becomes efficient. Okay, so in that case we have to see certain aspects of that algorithm. Okay, and the aspects would be the programming aspects, the time aspects, and the space aspects of that algorithm. So once we are in a scenario wherein we have to choose the algorithm, what we'll start doing is we'll start making a comparative study. That algorithm one, okay, what are the programming requirements, what are the time, and what are the space. Algorithm two, what is the programming, time, and space requirements. So that's how we are going to go about. So now what exactly they are? Okay, what do we mean to say this? Okay, so let's see. Fine. Now when we say programming requirements of algorithm, okay, what we are trying to tell is that okay, we have written an algorithm, okay, and of course that algorithm will be in a simpler language, in a language which everybody can understand. At times a person with a less technical knowledge also can understand. But down the line we don't have to forget it that these algorithm is something which we have to implement. Okay, just writing algorithm or having it and displaying it to 10 people is not going to solve the purpose. Okay, that algorithm has to be implemented. And when it has to be implemented, so what is algorithm? Instructions which we have to give to the machine. Okay, so that is only possible using a programming language. Yes, of course, the choice of programming language could be anything. Okay, so the point over here is that no matter how good the algorithm is written, the end result of that algorithm is that it has to be implemented. Okay, it has to be executed. It just can't sit on a piece of paper, okay, and say okay that yes, I am a good algorithm. No, it's not like that. Okay, algorithm has to be implemented. So now what if something is written in an algorithm and that feature is not supported by programming language? Okay, so let's say certain thing which is written in an algorithm, and what we see is the programming languages does not support that feature which is written into the algorithm. Of course, there is a very minimal chance of it, because programming language do come with immense capacities, and of course it is also a big skill of the developer and a programmer on how to code that thing. But what we are trying to tell over here, that if something which is written in algorithm, okay, which is just out of the box, okay, of course it's a very good idea, but it's just out of a box for a programming language to support, then in that case, though that algorithm is very optimal on a piece of a paper, or maybe by explanation it looks, yes, this is very good, this is the best way by which this problem could be solved. But yes, on the other side, when I start marking the technical aspect, that how I'm going to achieve this, and I get stuck up. Okay, these are the few things which are not possible. Okay, by there is no feasibility on how any programming language which is available will help me to achieve that. Then in this scenario, the other algorithm which may be not looking optimal as compared to this algorithm, but yes, because it is fully supported by a programming language, okay, that algorithm should be preferred as compared to this. Okay, so we have to understand, when we say programming analysis of an algorithm, okay, we are trying to focus on something which by that algorithm has to be programmed. Okay, it has to be, of course, optimal and efficient, but then one more care which has to be taken, that it has to be programmed. Okay, and yes, if it's a combination, that it is optimal and it can be programmed, then yes, it's going to be the best. Okay, so students, that was the very first analysis of an algorithm, that this is the way. So if you have 5 algorithms, okay, you have to first of all mark down that what about all these 5 algorithms, are they all programmable? It might come to a scenario, yes, all are programmable. That's then in that case you have to start going to the next analysis. Okay, now in the first case, let's say from 5 algorithm 3 is not programmable, okay, some part, then of course you might have to you might have to change it, or you might have to simply discard it or something like that. Okay, so that's the very first analysis that you have to go through. This is not the only analysis, this is the first level of analysis. Okay, because if it is going to be coded, then only the further analysis is going to make sense, as else it will not make sense. Okay, now what is the next analysis? Okay, the next analysis is about the space analysis. Okay, so we already know, okay, so, we are already aware. Okay, we say we talk about space a lot. Okay, how much memory is there, how much drive is there, etc., etc. Okay, so whenever we talk about space scenario, okay, that we know that to solve any problem, okay, or even to for any program to run, okay, we are in a requirement of space. So same way, when it comes to a program, okay, there are basically two needs because of which a program would be needing the space. Okay, so program will be needing the space for containing the data, and a program will be needing the space to run the instructions properly. Okay, so talking about the very simpler algorithm that we have talked just few minutes back, that there are two numbers and we have to add it. Okay, so what we saw is the data is n1 and n2 are nothing but acting as data. So I will need a space wherein that variables could be stored, and of course it will be dynamic because if today let's say it might tomorrow be possible that instead of n1 n2 and n1 and n2 there could be n1 n2 and n3. So in that case the space allocated will be will be dynamic. But let's say for example the program just restricts to their addition, then in that case the instruction will be only one. It will be today it can end n1 and n2, tomorrow it can end n1 n2 and n3. Okay, so the instruction part remains the same. So basically what we're trying to tell is that at times it also happens that on runtime certain certain more memories created. So point over here is that when we want to execute any program, okay, we will be in a need of space. Okay, and when we say space analysis of algorithm or space requirements of an algorithm, we are trying to say that an algorithm should be designed in such a way that the space requirements should be optimal. Okay, so let's say it shouldn't happen that the algorithm is the instructions are written in such a way that when we try to code that, okay, it is taking ample amount of space. Okay, though space is something which is available, but we know that all the programs work in a shared scenario where even a big amount of space is shared by multiple applications. So we do have to understand that the space requirements are also very important when we do the algorithm analysis. Okay, so what we saw that programming analysis will be the first one, and then the space analysis will be the next one. Okay, so what's next? Okay, now the most important and the critical analysis is nothing but the time analysis. Okay, now each algorithm takes some amount of time to execute. Okay, sometimes it is necessary to know in advance the time required to execute the program to see whether it is within the acceptable limits or not. Okay, over here simply I want to give you an example. Let's say there is some application that you are using and you are requesting something from that application. Okay, and let's say after your request it is taking 5 minutes to give you the answer. Okay, there is no need to take the name of application because there could be any application which can come into this category. What I want to say over here that if we are requesting something from application, okay, maybe we would be expecting certain output from the application, maybe we would be expecting certain information from the application, whatever it is. Okay, and if we have to wait for a longer amount of time, no, in that case I think we're not going to wait, the user is not going to wait. Okay, so that's what we're trying to tell over here, that okay, given an algorithm, okay, let's say the algorithm is fine enough, but let's say it's taking a time which is not acceptable into our limits. So in that case, let's say depending on algorithm we figure out, okay, if this is the scenario, then yes, okay, 2 minutes is something which is acceptable, or 1 minute is something which is acceptable. If we are getting response or output after 1 minute, that's absolutely fine. But what happens is when we code that algorithm and then we come to know, or let's say even by studying the algorithm, when we have other knowledges also, there is even no need to code the algorithm. Before coding it also, you can very well understand that how much time it is going to take. And if we figure out that it is going to take ample amount of time, then in this scenario, okay, we may not have to accept this algorithm, or we may have to do certain changes, or maybe we have to compare an algorithm which is much better into time requirements. Now, there can be several different solutions for a particular, each with different time requirement. One can choose the most optimal solution. Okay, so that's what we're trying to say, that there could be several solutions available, but then yes, we have to give utmost importance to the time requirement, and we have to choose the one which is going to take the minimal amount of time, or maybe the optimal amount of time. Now, so, see, calculating the understanding the programming requirements is very easy. Okay, on a first glance itself, seeing the algorithm, you can understand, or we can understand whether the programming requirements, can be followed or not. The space requirements can be followed or not. But to calculate and understand the time requirements will not be very easy, because when these algorithm is going to be programmed, and let's say it is executing on a machine. Now, the algorithm, let's say, on one machine on which it executes, that machine has a very high processor, and on the other machine in which it is executing, it's very low processor. Then in this scenario also, what happens, that uh, it's going to take different amount of time, because the processing capacity of first machine was very high. So point over here is that when I'm going to do an analysis of algorithm, do I have to, or do we have to consider this thing also? Because if we consider this thing, then it is never going to end. Okay, then in none of the scenario, we will be able to understand what is the time analysis of the algorithm. So when we talk about that, we have to understand about the time analysis of the algorithm. We don't have to consider it. Okay, and algorithm should be chosen in such a way that even if runs on several machines, okay, with different capacities, there has to be very less negligible difference. Okay, when it comes to the behavior. So that's what it has to be. So it is not very easy to calculate the exact time requirement for any algorithm, as it depends upon the various factors, like machine on which the algorithm is to be executed, the algorithm itself, and the input size of the algorithm. Okay, again over here, let's say if an algorithm is having processing of data, and let's say the data processing is 20. Just giving a very simple example, let's say we have to write an algorithm to process, or let's say to sort 20 integers, and we have to write an algorithm to sort, let's say, 20,000 integers. 20,000 integers over here also, the time is going to be different for first one and the second one. So that's why when we talk about time analysis, it is not very easy, because in many scenarios it can differ also because the processor speed in different machines may be different. So we mainly concentrate to estimate the execution time of the algorithm, irrespective to the processor or the machine. Okay, so here we focus on that. Okay, independent of any machine, how these algorithm is going to take the time. Okay, what is going to be the rough estimation? So let's say it comes around that these algorithm is going to take 4 minutes. So it might happen that depending on a machine, some machine may execute it into 3.8 seconds, 3.9 seconds, and let's say some will be into 4.1. Yes, but there will always be a limit. Okay, that in this to this limit, they will be the algorithm is going to be executed. So when we do the time analysis of the algorithm, the first thing has to be taken care of, that irrespective of what data that algorithm is taking, irrespective on which processor or machine it is going to work off, okay, that factor should not be considered. And apart from that, okay, in again a logical manner, it has to be find out that how much time requirement is going to be taken by an algorithm. This itself is a study. Okay, and it's a depth of what we call as algorithm analysis also. Okay, fine. So that's what about time analysis of algorithm. Now, so what we saw till now is why algorithm analysis should be there, and what are the three kind of analysis that we should do in an algorithm. Now we come to a topic wherein we say what is the complexity of an algorithm. So how I'm going to find out the complexity factor. Okay, when I say complexity factor, which means I want to say how the algorithm is going to behave. Okay, so is the algorithm going to behave in a good way, or maybe in a less in an average way, or the algorithm is going to behave in a best way. Now, how do we understand that? So again, complexity is majorly focused on space and time requirements. So if I want to know the complexity of an algorithm, my major focus would be to understand the space and time analysis of the algorithm. Now, if the time and space requirement of an algorithm is more, then the complexity is more. And if the time and space requirement of the algorithm is less, the complexity is less. Okay. So what we are trying to tell here, that how complex the algorithm is, how we are going to define it. So if the algorithm is going to take large amount of space, large amount of time, then okay, we will see that this algorithm is very complex. Okay. And if the algorithm is taking less space and less time, then it will be said that the algorithm is less complex. Now, from these two factors, okay, the space requirement is not very important because it is available at very low cost. Okay, if you want to, um, migrate from 1 GB to 2 GB, it's not going to take a lot amount of cost for you. Okay, but let's say the time requirement is going to be, very, 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 very important factor, because it will it is directly dependent on a processor, and we all know that there is only one processor available which has to perform multiple applications. So if all the resources of the processor are just stuck on doing or running the same application, then it might happen that user will not be able to get the output of the current application, neither the other applications will be able to run. So therefore time requirement is very, very, very important. Now, so how we should understand it, and how we should we should calculate it. Now there is an example that is given. Taking an example, consider an array which sorts of size 2000 will definitely take more time than to sort an array of size 20. Thus time complexity is explained in terms of input size n. Okay. So students, as we have seen uh, over here also, okay, that uh, it will not be very easy to understand that how much time the algorithm is going to take, because it will depend on multiple things, like on which machine it is going to work, what is the input size. Okay, so here, because we are not aware of the input size, okay, on a very preliminary level, at least we can understand the time complexity, whether the algorithm is going to be behaving good or not good on the basis of the size. Okay, here it does not mean that uh, that the time analysis of the algorithm is changing if the input size is more or less. See, understand what we are trying to tell is that we know that if we have to sort an array of 2000, the time will be more, and if you want to sort an array of 20, the time will be less. Okay, that is something that we are already aware of. But our let's say the way of choosing algorithm should be such that even in a scenario where the array size is 20, okay, the behavior of the algorithm should be same. And even in a scenario where the size is 2000, the behavior of the algorithm should be same. Okay, so that behavior, okay, should remain same. And the size, if the size grows, then there will be very, very, very less time difference. Okay, so we have to much talk about the behavior of algorithm, okay, irrespective in whatever data size it is going to work. Okay, so that's how it has to be calculated. So yeah, we will be understanding this much more better when we see what are the complexities and how what do they mean. So the types of complexity are worst case complexity, best case, and the average case. Okay, so let's see the first one, worst case complexity. If the running time of algorithm is longest for all inputs, then the complexity is called the worst case complexity. So students over here, please understand what we are trying to say, that the algorithm is taking large amount of time even there is 20 elements to sort, and it is also taking large amount of time even there is 2000 elements to sort. Then in this case, we can surely say that this algorithm is not good, because irrespective of the data elements it is having, or irrespective of the inputs it is having, whether it is 10, 20, 30, 40, 50 or 60, it is taking, let's say, more than 5 minutes only. So that scenario or that kind of complexity of time will be worst, and in that case we will say that this algorithm belongs to worst case complexity. Again, remember, when we say complexity is not good, when the space and time requirements are very high. Okay, so here the time requirement is very high, and that's why we will say the complexity is not good and it's worst. In this type of complexity, the key operation is executed maximum number of times. Okay, so giving you an example of again sorting, what is the key operation in sorting? You know, you have to compare and then you have to swap. That is the basic operation. So compare, swap, compare, swap, compare, swap. So now if there is an algorithm in which, let's say, for 20 data elements, this same operation is performed 20 times, okay, almost the same number of times the data elements are there, then we can understand, okay, that it is a worst case. Okay, it has to do this thing for 20 number of times to get us the output. So in this case the time all taken will also be less. Okay, so yes, in this scenario we will call that it is in behaving in worst case complexity because it is taking maximum number of time, to execute that key operation. Now there are many applications wherein, of course, whenever even an algorithm is accepted, okay, then even the worst case complexity of that algorithm is being calculated. Okay, so let's say at times it can also happen that due to some situations or certain inputs, the algorithm could go into the worst case complexity also. So what happens is that it is always calculated the worst case complexity, and it is always defined as upper bound, which means in rare situations, okay, it should reach the worst case complexity. So there are again 5 algorithms available to you, and what you see is from these 5 algorithms, these are the only 5 algorithms to solve this problem. And what you see is from these 5 algorithms, algorithm 5 is taking maximum time. Okay, and let's say it is 5 minutes. Okay, so what will be the upper bound for 1, 2, 3, and 4, 5 minutes? Okay, so very rare situations they should be able to reach there, or else that should be the upper bound for them. Okay, and that always should be a comparison for the remaining algorithms. Now, best case complexity, if the running time of the algorithm is shortest for all inputs, then the complexity is called the best case. Okay, which means even if you have an array of 20 elements or 2000 elements, but it is taking the small number of time. Okay, so let's say for 20 elements it takes 1 second, and for 2000 elements it takes 1.5 seconds. Yes, in that case we will say that these algorithm is behaving in best case complexity, irrespective of whatever inputs it is getting, it is always giving its best. So these what exactly we see over here, that the time analysis of this algorithm is good, and that's why it belongs to the best case complexity. And what will happen over here, the key operation will be performed minimal number of times. So the logic will be written in such a smooth manner, that rather, now if you talk about previous case, let's say if there are 20 elements, and if you need to check and swap all the 20 elements, that's the manual process that we are doing. Okay, and we know it's going to take time. So where's the logic part into it? Okay, but yes, when someone trying to, when someone is, let's say, trying to encompass it the some logic, okay, which is very good, and then what will happen, that will not be the same scenario that will happen. It will not be like that before 20 swappings were happening. Now because of logic which is written, from those 20 swappings it might just come to 50% or even maybe less than that. So in this scenario what will happen, the key operation will be reduced to maybe 50% or even maybe less than that. So in this case, yes, we can say that the algorithm is having the best case complexity. And the last one is the average case complexity. So if the running time of the algorithm falls between the worst case and the best case, okay, then so now it's good time to understand what exactly we want to say. So initially we took an example that for a same solution there are 5 different algorithms available. Now what happens is, after the analysis of the time and everything, algorithm 3 is taking, let's say, 4 minutes. That is, let's say, the worst complexity, because that is the highest amount of time which is being taken. And then what happens is algorithm 5 is taking, let's say, 1 minute. So that is the lowest time, okay, which it is taken, which means all of the algorithms, okay, cannot work in less than 1 minute. Okay, none from 5 algorithms, the minimum time, that is, which means if you want to solve this problem, there is a minimum time of 1 minute which has to be given, or which has to be taken. and the maximum possible time could be 4 minutes, and it should not be more than that. So now all the other algorithms, okay, are somewhere into the average case, okay, because it might happen that in this case algorithm 1 may take 1.5 minutes, 2 minutes, 3 minutes, okay. It may also happen that in certain scenario algorithm 4, okay, which is again in average case, may take 1 minute also, okay, or 1.1, which is exactly, very similar to the best case. And then it might also happen that algorithm some another algorithm will almost, go near to 3.8 minutes or something like that. So point over here is that from all the available algorithms, okay, there will be one which will be sufficing the need of the worst case complexity, which will always be the upper bound, that is the maximum number of time which should be taken by these problem to get solved. And there will be a best case algorithm, which means which will define the minimal amount of time which has to be taken um, by a problem to solve it, okay. And then the rest of the other approaches will somewhere be in between from this lower bound and upper bound. So in these case, we call that these all belongs to the average case complexity. And of course, we have to take certain assumptions in the sense that if I want to calculate the average case, okay, then I have to take first of all certain assumptions to fix my best case and the worst case, okay. So why over here we are telling assumptions that we have got just five, algorithms. There could be certain more, okay, there could be a few more which can solve the problem, but that's not available to us. So we are assuming that these algorithm 5 is going to be the worst case, okay, and these algorithm 2 is going to be the best case, and then only it will be possible for us to calculate the average case of the algorithm. So that's what was the complexities of algorithm: worst case, best case, average case, okay. Though to find out the complexity, there are actually two things which we should. Hello.